Close your eyes now and take a slow, deep breath in through your nose, drawing in the infinite peace of the universe. Hold it gently for a moment, feeling yourself become lighter, weightless. And now release it softly through your mouth, letting all the heaviness of Earth fall away like stardust dispersing into the cosmic void. Tonight, we're embarking on the most peaceful journey imaginable, a gentle drift through our home galaxy, the Milky Way. You won't be traveling in a spacecraft or wearing a spacesuit. Instead, you're simply floating. Consciousness itself, drifting through the velvet darkness of space, wrapped in a soft glow of 100 billion stars, cradled by gravity so gentle it feels like the universe itself is holding you in its arms. Imagine yourself now, suspended in the perfect silence of space. The darkness around you isn't empty or frightening, it's full of possibility, full of ancient light, warm and welcoming as a cosmic embrace. Below you, though in space there is no below, you can see the gentle curve of our galaxy, the Milky Way, spread out like a luminous river flowing through the void. From this vantage point, countless light years from any planet, you can see what astronomers tell us is true. Our galaxy is shaped like a vast spiral, over 100,000 light years from edge to edge, slowly rotating like a celestial pinwheel in the darkness. Take another deep breath, and feel yourself sinking deeper into this peaceful drift. The Milky Way contains between 100 billion and 400 billion stars, each one a sun like ours or vastly different, and you're going to visit some of them tonight. But there's no rush. Time moves differently here in the cosmic ocean. 1,000 years can pass in a moment, or a moment can stretch into eternity. You have all the time in the universe. The silence wraps around you gently, complete and profound. In space, there is nowhere to carry sound, so what you experience is the purest quiet imaginable, not the absence of sound, but the presence of peace. Some astronauts who've experienced this silence describe it as meditative, as though the universe is breathing with them, its vast presence felt rather than heard. You feel that presence now, supportive and serene, as ancient as time itself. You notice that you're slowly rotating, tumbling gently in zero gravity, and with each lazy turn, you see different aspects of the galaxy. The Milky Way's spiral arms curve outward from the bright center like rivers of light, streams of stars, gas, and cosmic dust, flowing through space in patterns that have taken billions of years to form. Our galaxy rotates once every 250 million years, a period sometimes called a cosmic year. In all of human history, from the first civilizations to this very moment, the Milky Way has completed less than 1/100th of a single rotation. This is the timescale of galaxies, patient, eternal, unhurried. From where you float, you can see that the Milky Way isn't alone in the universe. Faint smudges of light in the distance are other galaxies, the Andromeda Galaxy, our largest neighbor, visible as a soft oval glow. Andromeda is actually moving toward us, and in about 4 billion years, our two galaxies will merge in a slow, graceful collision that will take hundreds of millions of years to complete. But tonight, both galaxies exist in peaceful coexistence, separated by 2.5 million light-years of empty space, each one a vast island of stars in the cosmic ocean. Everything feels perfectly still here, suspended in the infinite. Your breathing has slowed to match the patient rhythm of the cosmos. Your body feels weightless, free from all tension, all worry, all sense of time pressing forward. Here in the darkness between stars, there is only now, only this peaceful floating, only the gentle glow of distant suns to keep you company. As you drift, you begin to descend slowly, so slowly, toward one of the Milky Way's spiral arms. This is the Orion Arm, also called the Orion Spur, where our own solar system resides. It's a minor arm, a small branch between two of the galaxy's major spirals, the Perseus Arm and the Sagittarius Arm. Our Sun, and Earth, and everything humanity has ever known, sits about 26,000 light-years from the galactic center, in what astronomers describe as the galactic habitable zone, not too close to the chaotic center, not too far out in the sparse edges, but in a peaceful middle distance where stars are spaced comfortably apart and conditions are stable enough for life to emerge and flourish. Your gentle descent continues, and now you're drifting into the Orion Arm itself, surrounded by stars on all sides. The darkness is no longer quite so dark. Here within the spiral arm, stars are close enough that their combined light creates a soft, ambient glow, like twilight on Earth but from all directions at once. The light is mostly white and blue-white, coming from young, hot stars that were born relatively recently in cosmic terms, within the last few 100 million years. Stars in the spiral arms of galaxies tend to be younger than those in other regions, because the spiral arms are where star formation happens most actively. As clouds of gas and dust orbit the galaxy, they compress when they pass through the spiral arms, and this compression triggers the collapse of the clouds into new stars. The Orion Arm where you're floating now is one of these stellar nurseries, though nursery seems too energetic a word for something so peaceful. Here, stars are born in silence, condensing out of cosmic gas over millions of years, their nuclear fires igniting without sound or fanfare, adding their light to the galactic glow. You drift past a young star cluster, a group of several hundred stars, all born from the same giant cloud of gas and dust, all roughly the same age, like siblings scattered across a few light years of space. Star clusters like this one will eventually disperse as the galaxy's rotation pulls the stars in different directions, but for now, in their youth, they remain loosely bound together by mutual gravity. The stars are predominantly blue and white, colors that indicate their tremendous heat, surface temperatures of 20,000 to 30,000 degrees Celsius, far hotter than our yellow sun. The silence continues to wrap around you, comfortable as a blanket. Everything feels perfectly still, despite the fact that you're actually moving at incredible speeds. The Orion Arm, like everything in the galaxy, orbits the galactic center at about 500,000 miles per hour. Earth, orbiting our sun, is also moving through space at 67,000 miles per hour. And the sun itself is moving through the local neighborhood of stars at about 45,000 miles per hour. Yet none of this motion is perceptible. In the vastness of space, even speeds that would seem impossibly fast on Earth produce only the gentlest, most peaceful drift. You notice wisps of gas between the stars, faint glows of red and blue and green, like cosmic aurora. This is the interstellar medium, the thin gas that fills the space between stars. It's mostly hydrogen, the simplest and most abundant element in the universe, with traces of helium and tiny amounts of heavier elements. The density of this gas is almost incomprehensibly low. In the regions between stars, there might be only one atom per cubic centimeter, compared to trillions of molecules in the same volume of air on Earth. Yet in the galaxy's vast spaces, even this impossibly thin gas adds up. The interstellar medium contains as much mass as all the stars in the galaxy combined, a cosmic reservoir from which new stars are constantly being born. Some of the gas glows faintly, illuminated by ultraviolet light from nearby young stars. These glowing regions are called emission nebulae, and they paint the darkness with subtle colors: red from hydrogen, blue-green from oxygen, red and green from nitrogen. The colors are soft, nothing like the vivid hues you might see in processed astronomical photographs. To human eyes, these nebulae would appear as gentle, ghostly glows, their light so faint that your eyes would need hours to fully dark adapt before you could see them clearly. But here, in your peaceful drift through the cosmos, you can see them perfectly, subtle watercolor washes on the canvas of space. As you float deeper into the spiral arm, you pass through a dark region, a cloud of dust so thick it blocks the light from stars beyond. But rather than frightening, this darkness feels protective, like floating through a cosmic cave. The dust is made of tiny particles, each one microscopic, composed of carbon, silicon, and other elements forged in the hearts of ancient stars and then ejected into space when those stars died. This dust will eventually coalesce into new stars and planets, continuing the cycle of stellar birth and death that has repeated countless times since the galaxy formed 13 billion years ago, just 600 million years after the Big Bang itself. Everything feels perfectly still in this dark cloud. The dust blocks visible light, but it glows faintly in infrared, warmed by the distant stars around it. If you could see in infrared, this dark cloud would appear as a warm, comforting glow, like embers in a cosmic fireplace. You float through it slowly, peacefully, knowing that you're drifting through the raw material of future solar systems, future planets, perhaps even future life. Emerging from the dark cloud, you find yourself in a region rich with stars. They surround you like fireflies on a summer evening, some close enough that you could almost imagine reaching out to touch them, others distant points of light millions of miles away. Each star is a nuclear fusion reactor, converting hydrogen into helium in its core, releasing energy that pours into space as light and heat. The process is extraordinarily efficient. A star like our Sun converts about 600 million tons of hydrogen into helium every second, and yet it has enough fuel to continue doing this for 10 billion years. Our Sun is currently about halfway through its life, at 4.5 billion years old, comfortably middle-aged, stable and reliable. You drift toward one particular star, curious. As you approach, you see that it's larger than our Sun, a red giant, a star that has exhausted the hydrogen in its core and expanded to hundreds of times its former size. The surface glows a deep orange red, much cooler than the Sun's yellow-white surface, but producing far more total light because of its enormous size. This star might once have been like our Sun, but now it's in the late stages of its life, having swelled up to engulf the orbits of what were once its inner planets. In a few million years, a cosmic eye blink, this star will shed its outer layers into space, creating a planetary nebula, while its core contracts into a white dwarf star no larger than Earth but containing as much mass as the Sun. The silence around the red giant is profound. You float in its faint orange glow, feeling the gentle warmth of its light on your consciousness. Nothing is hurried here. The star will continue its patient fusion for millions of years more before its final transformation. Time, you realize, is different for stars than for humans. A star's life unfolds over billions of years, its changes too slow to perceive in any human lifetime. This patient pace is soothing, a reminder that not everything in the universe rushes forward. Some things simply exist, burning steadily, shining faithfully, taking all the time they need. Moving on, you encounter a binary star system, two stars orbiting each other, bound together by gravity in a cosmic dance that has continued for billions of years. One star is larger and brighter, a blue-white giant. The other is smaller, yellower, more like our sun. They orbit their common center of mass once every few days, perpetually falling toward each other but also perpetually moving sideways, so they never collide, trapped in an eternal embrace. About half of all stars in the Milky Way exist in binary or multiple star systems like this one, cosmic partnerships that last for billions of years. You watch the binary system for what feels like hours, mesmerized by the slow dance of the two stars. Everything feels perfectly still, yet everything is moving in graceful arcs through space. The larger star's gravity pulls on the smaller one, creating tidal bulges on its surface. In some binary systems, gas from one star flows toward the other, creating streamers of glowing plasma between them. But this system is more sedate, the two stars orbiting at a distance that prevents such dramatic interactions. They simply exist together, two lights in the darkness, companions in the cosmic night. Continuing your drift, you pass through a region where stars are more densely packed, not a formal cluster, but a casual congregation of a few dozen stars, all moving in roughly the same direction through the galaxy. Our sun was likely born in such a group, along with thousands of siblings from the same giant molecular cloud. Those stellar siblings have long since scattered throughout the galaxy, carried apart by the differential rotation of the Milky Way, but they still exist somewhere, scattered across thousands of light years, each one carrying with it the memory of that ancient birth cloud. You notice that stars come in an incredible variety. Some are tiny red dwarfs, barely massive enough to sustain fusion, glowing with a dim red light that could continue for trillions of years, longer than the current age of the universe. Red dwarfs are the most common type of star in the galaxy, making up about 70 to 80% of all stars, though they're so dim that none are visible to the naked eye from Earth. Other stars are massive blue giants, burning through their fuel at tremendous rates, living fast and dying young in spectacular supernova explosions after only a few million years. The silence wraps around you gently as you drift among these varied stars. Each one is a world unto itself, a sphere of plasma held together by its own gravity, generating energy through the same fundamental process but expressing it in endlessly varied ways depending on its mass, age, and composition. The universe is conservative with its building blocks. Stars are all made primarily of hydrogen and helium, but it's infinitely creative with what it does with those simple ingredients. Your peaceful drift carries you toward a region where the darkness is painted with color. Ahead, you see one of the Milky Way's great nebulae, a vast cloud of gas and dust, glowing in shades of red and pink, illuminated from within by newly formed stars. This is an emission nebula, a stellar nursery where stars are being born right now, this very moment, continuing a process that has unfolded billions of times throughout the galaxy's history. As you drift closer, the nebula fills your vision. It's vast, stretching across dozens of light years, its edges fading gradually into the darkness. The predominant color is red, the characteristic glow of hydrogen gas excited by ultraviolet light from young, hot stars embedded within the cloud. But there are other colors too, teal from oxygen, purple from nitrogen, each element contributing its unique signature to the overall glow. The Eagle Nebula, one of the Milky Way's famous star-forming regions, lies about 7,000 light-years from Earth and contains the famous pillars of creation, towering columns of gas and dust where stars are actively forming. Though you're not visiting the Eagle Nebula specifically, the nebula before you is similar, a place where gravity is slowly pulling gas together into denser clumps that will eventually become stars. The process takes millions of years, proceeding with such patient slowness that even if you watched for a human lifetime, you perceive no change. You float into the nebula itself, and the experience is like drifting through a cosmic mist. The gas is far too thin to see as a fog would appear on Earth. You could hold out your hand and see it clearly, unobscured. But all around you, stretching in every direction, the gas glows faintly, creating an ambient light that turns the darkness into a gentle, luminous twilight. The silence continues, profound and complete. Even here, in a region full of matter and energy, there's no sound, no roar of stellar winds, no crackling of magnetic fields, just perfect, peaceful quiet. Within the nebula, you discover a group of protostars, stars in the process of being born. They're still shrouded in thick cocoons of dust that hide them from visible light, but their presence is betrayed by the infrared glow of their warming cocoons and by the jets of gas they're blasting into space from their poles. These jets, moving at hundreds of miles per second, clear away some of the surrounding material, carving channels through the nebula. But even these violent processes unfold in perfect silence, perceived only as gentle changes in the distribution of glowing gas. Everything feels perfectly still here, despite the tremendous energies involved in star formation. The protostars are heating to millions of degrees at their cores, on the verge of igniting the fusion reactions that will sustain them for billions of years. But all of this happens slowly by human standards, over timescales of millions of years. The universe is patient. It has all the time in existence to accomplish its works. You drift past a particularly striking formation, a dark globule of dense dust silhouetted against the glowing nebula behind it. This is a Bach globule, a small, dark cloud that might be collapsing to form a single star or a small group of stars. It looks like a hole in the glowing background, a circular shadow about 1 light-year across. Bach globules are some of the coldest places in the galaxy, with temperatures only 10 or 20 degrees above absolute zero. Yet even in this extreme cold, processes are unfolding, molecules forming, dust grains colliding and sticking together, gravity slowly drawing everything inward. As you emerge from the far side of the nebula, you look back at it, seeing the whole magnificent structure spread out like a cosmic tapestry. The nebula will exist for millions of years more, its gas gradually consumed by the formation of new stars, until eventually it disperses, leaving behind a new star cluster where there was once a glowing cloud. The stars will then slowly drift apart, scattered by the rotation of the galaxy, until no trace remains of their common origin except for subtle similarities in their ages and compositions. Your journey continues, and you find yourself approaching a star with a planetary system. This isn't our sun. You're still thousands of light years from home, but it's remarkably similar. A yellow dwarf star, stable and long-lived, surrounded by a family of planets that have orbited it for billions of years. Astronomers estimate that most stars in the Milky Way have at least one planet, which means there might be as many as 400 billion planets in our galaxy alone. The universe, it seems, loves to make planets just as much as it loves to make stars. You drift toward the inner region of this planetary system, where rocky planets orbit close to the star's warmth. The nearest planet is a scorched world, tidally locked so that one side always faces the star, perpetual day on one hemisphere, eternal night on the other. This planet is too close to its star to support life as we know it, its surface baked to temperatures high enough to melt lead. But it's strangely beautiful nonetheless, its day side glowing red hot, its night side cooling to merely uncomfortable temperatures, with powerful winds racing from day to night, trying futilely to equalize the temperature difference. Moving outward, you encounter another rocky planet, this one in what astronomers call the habitable zone, the orbital distance where liquid water can exist on a planet's surface. This planet has oceans, continents, an atmosphere of nitrogen and oxygen, wispy clouds that drift across blue skies. You can't know if life exists here, that would require closer examination, but the conditions certainly seem right. The planet completes one orbit of its star every 400 days, giving it seasons similar to Earth's as its tilted axis points different hemispheres toward and away from the star during different parts of its year. The silence wraps around you gently as you contemplate this potentially life-bearing world. The universe is so vast, containing so many stars and planets, that the existence of life seems not just possible but probable, perhaps even inevitable. Astronomers haven't yet found definitive evidence of life beyond Earth, but they've found thousands of exoplanets, planets orbiting other stars, and many of them orbit in their stars' habitable zones. The question isn't whether life exists elsewhere in the galaxy, but how common it is and whether intelligent, technological civilizations arise often or rarely. Continuing outward through the system, you pass gas giants, planets similar to Jupiter and Saturn, massive worlds made mostly of hydrogen and helium, with no solid surface, just atmosphere that gradually compresses into liquid and then exotic metallic states deep in their interiors. One of these giants has a magnificent ring system, thin sheets of ice and rock that orbit the planet in its equatorial plane, sparkling in the reflected light of the distant star. The rings cast shadows on the planet's cloud tops, creating delicate dark bands that shift as the planet rotates. Everything feels perfectly still as you float among these worlds. The planets move in their orbits, of course, traveling at tens of thousands of miles per hour, but the motion is smooth and imperceptible, a cosmic waltz that has continued for billions of years. The gas giant takes 12 years to orbit its star once. The rocky planet in the habitable zone completes its year in 400 days, and the scorched inner world races around in just 40 days. Yet all these different rhythms coexist peacefully, the result of the gravitational choreography that shaped the system when it formed from a collapsing cloud of gas and dust 4.5 billion years ago. Far beyond the planets, at the very edge of the system, you encounter the region where comets originate, a vast, spherical cloud of icy bodies that extends halfway to the nearest star. This is analogous to our solar system's Oort cloud, a reservoir of billions or trillions of comets that rarely venture into the inner system but occasionally get perturbed by passing stars, sending them on long, elliptical orbits that carry them close to the star before flinging them back into the darkness. These comets are remnants of the system's formation, pristine samples of the original material that built the planets, preserved in deep freeze for billions of years. Leaving the planetary system behind, you drift back into the space between stars, the local neighborhood of our sun, though you're still far from home, thousands of light years away. Here, stars are spaced an average of about 4 light years apart, vast emptiness punctuated by points of light. The nearest star to our sun, Proxima Centauri, is 4.24 light years away, a distance so great that light, traveling at 186,000 miles per second, takes over 4 years to cross it. If the sun were the size of a period at the end of a sentence, Proxima Centauri would be another period about 10 miles away. This vast emptiness is peaceful rather than lonely. The darkness is complete, undisturbed by nearby light sources, allowing the distant glow of the Milky Way to be fully visible. From here, in the space between stars, you can see the galaxy's structure more clearly, the bright band of the galactic disk stretching across the sky, denser regions marking the spiral arms, the bright glow of the galactic center in one direction, the sparser regions toward the galactic edge in the other. The view is breathtaking in its scope, a reminder that you're not just near a few stars but are part of a vast system containing hundreds of billions of them. The silence continues to wrap around you, comfortable and complete. Everything feels perfectly still here in the interstellar void. Time seems to slow, or perhaps it simply becomes irrelevant. 1,000,000 years from now, these same stars will still be shining, barely moved from their current positions despite traveling at thousands of miles per hour through space. The galaxy rotates so slowly, and space is so vast, that the stellar neighborhood changes only on timescales of millions of years. You notice something remarkable, even here, between the stars, you're not in truly empty space. Cosmic rays pass through you constantly, high-energy particles accelerated to nearly the speed of light by supernova explosions and other violent events, traveling for millions of years across the galaxy. You also drift through the local interstellar cloud, a region of slightly denser gas that our solar system is currently passing through. This cloud has a density of about 0.3 atoms per cubic centimeter, still a vacuum far better than anything achievable in laboratories on Earth, but enough to create a subtle glow when viewed with the right instruments. The temperature of this interstellar space is about 6,000 degrees Celsius, which seems impossibly hot until you realize that temperature measures the average energy of particles, and here there are so few particles that even though each one is moving quickly, there's no substance to transfer that heat to you. You would not feel hot here, you would feel nothing at all, suspended in perfect thermal equilibrium with the cosmic microwave background radiation that fills all of space, the ancient afterglow of the Big Bang itself, cooled over billions of years to just 2.7 degrees above absolute zero. As you drift, you become aware of the magnetic field that permeates the galaxy. It's weak, thousands of times weaker than Earth's magnetic field, but it stretches across vast distances, following and shaping the flow of ionized gas through the galaxy. This magnetic field plays a role in star formation, providing support against gravity's pull and influencing how gas clouds collapse. It also channels cosmic rays, creating invisible highways that guide these high-energy particles as they spiral through the galaxy. Everything feels perfectly still, yet you're becoming increasingly aware that stillness in space is relative. You're moving through the galaxy at hundreds of thousands of miles per hour. The galaxy itself is moving through space at hundreds of miles per second, falling toward the Virgo cluster of galaxies under the influence of gravity. And the local group of galaxies, including the Milky Way and Andromeda, is moving at over 370 miles per second relative to the cosmic microwave background, pulled by the gravitational influence of an enormous supercluster of galaxies called Laniakea. Motion upon motion upon motion, yet all of it so smooth and vast that it feels like perfect peace. Your peaceful drift takes you into a profound realization. The light you see from distant stars left those stars years, decades, or centuries ago. That bright star in the distance, its light has been traveling for 500 years to reach this point in space where you're floating. When that light began its journey, humans on Earth were in the Renaissance. Leonardo da Vinci was painting the Mona Lisa, and no one had yet imagined that the Earth orbited the Sun rather than the other way around. The galaxy is not just vast in space, it's vast in time. When you look at distant stars, you're looking into the past. The farther away a star is, the further back in time you're seeing it. That cluster of stars 10,000 light years away, you're seeing them as they were 10,000 years ago, when humans on Earth were just developing agriculture and building the first settlements. Those stars might have changed in the intervening millennia. Some might have aged and swelled into red giants. A few might have exploded as supernovae. But you won't see those changes until their light completes its long journey across the galaxy. This thought fills you with a strange peace. The light carries with it a message from the past, a photon that began its journey before recorded human history, traveling at the ultimate cosmic speed limit through the vacuum of space, and finally arriving, here, now, where you're floating in the cosmic darkness. Each photon is a time traveler, a messenger carrying information across the vast distances and vast timescales of the galaxy. The silence wraps around you gently as you contemplate this. The galaxy is not just a collection of stars existing in the present moment, it's a four-dimensional structure stretching through both space and time. When astronomers look at distant galaxies billions of light years away, they see those galaxies as they existed billions of years ago, in the early universe, not long after they formed. In a real sense, looking deeper into space is looking further back in time. You drift toward an old globular cluster, a dense, spherical collection of hundreds of thousands of stars, all orbiting the galaxy together. Globular clusters are among the oldest structures in the Milky Way, formed over 12 billion years ago, not long after the galaxy itself came into existence. The stars in this cluster are ancient, many of them red giants and red dwarfs, stars with very little of the heavier elements that were created in later generations of stars. These are population 2 stars, formed from gas that was almost pure hydrogen and helium, before supernovae had enriched the interstellar medium with carbon, oxygen, iron, and other elements necessary for planets and life. The cluster is beautiful in its antiquity. The stars are packed more densely here than anywhere else in the galaxy. In the cluster's core, stars might be separated by only a few light days rather than light years. If you stood on a planet orbiting one of these stars, the night sky would be filled with hundreds of stars bright enough to cast shadows, a sight so magnificent it would make Earth's night sky seem sparse by comparison. Everything feels perfectly still within the cluster. These stars have orbited each other for over 12 billion years, held together by their mutual gravity, their orbits stable and predictable. The cluster itself orbits the Milky Way, taking about 200 million years to complete one orbit, swinging in a long ellipse that carries it high above the galactic plane before plunging back down through it. The cluster has witnessed the entire history of the galaxy, present when the Milky Way was young and still forming, persisting through billions of years of cosmic evolution. As you float among these ancient stars, you feel a deep connection to the passage of time. These stars were born when the universe was less than 2 billion years old. They have shone steadily for longer than Earth has existed. They watched as the Milky Way grew through the accretion of smaller galaxies, as its spiral arms formed and dissolved and reformed, as generation after generation of stars were born, lived, and died. And they will continue to shine for billions of years more, their long lives a testament to the universe's patience and persistence. Your journey now carries you inward, toward the heart of the Milky Way, the galactic center, located about 26,000 light-years from our solar system. As you drift closer, the density of stars increases. Space becomes less empty, the darkness less complete, as more and more suns add their light to the ambient glow. Here, in the inner regions of the galaxy, stars are packed more tightly together, hundreds of times more densely than in our solar neighborhood. The galactic center itself is hidden behind thick clouds of dust that block visible light, but if you could see in infrared or radio wavelengths, you would perceive a region of incredible complexity and energy. At the very heart of the galaxy sits Sagittarius A*, a supermassive black hole containing about 4 million times the mass of our Sun, packed into a region smaller than the orbit of Mercury. This black hole doesn't glow itself. Black holes by definition don't emit light, but the accretion disk of gas swirling into it glows brightly, heated to millions of degrees by friction and gravitational forces. Despite its tremendous mass, Sagittarius A* is remarkably quiet right now. In some galaxies, the central supermassive black hole actively feeds on infalling matter, creating blazing quasars that outshine all the stars in the galaxy combined. But our galaxy's black hole is quiescent, consuming matter only slowly, producing relatively little radiation. This gentleness is fortunate for life in the galaxy. An active galactic nucleus would flood the galaxy with radiation harmful to any biology within thousands of light years. You drift closer, maintaining a respectful distance from the event horizon, that boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. Even from here, far outside the danger zone, you can sense the immense gravitational field, space itself warped by the concentration of mass, time flowing slightly slower here than in the outer galaxy. The black hole's event horizon is surprisingly small given its mass, only about 24 million kilometers across, smaller than the orbit of Mercury. Yet within that tiny volume, relative to the galaxy, exists a mass 4 million times that of our Sun. The silence continues, profound and complete. Black holes are often described as violent, destructive objects, but that's not quite accurate. They're simply regions where gravity has become so strong that not even light can escape. From a safe distance, a black hole is just another gravitational object, no more dangerous than any other concentration of mass. You could orbit a black hole just as easily as you orbit a star, as long as you maintain sufficient distance and speed. The danger comes only from crossing the event horizon, and that's a journey you're not taking tonight. Everything feels perfectly still here, though the space around the black hole is anything but empty. Stars orbit Sagittarius A* in elliptical paths, some swooping incredibly close. One star, designated S2, approaches within just 17 light hours of the event horizon once every 16 years, reaching speeds of up to 5,000 kilometers per second at its closest approach. These stars are cosmic speedsters, their rapid orbits among the most direct evidence for the black hole's existence and mass. Around the galactic center, you notice the central bulge, a roughly spherical concentration of old stars that gives the Milky Way its distinctive profile when viewed edge-on. This bulge contains billions of stars, mostly ancient red and yellow stars similar to our Sun but much older. The bulge formed early in the galaxy's history, possibly when the Milky Way collided with and absorbed smaller galaxies, their stars gravitationally scattered into this central concentration. The view from here is extraordinary. Looking outward, away from the galactic center, you can see the spiral arms spreading out like cosmic pinwheels, lanes of bright blue stars marking regions of active star formation, darker dust lanes following the inner edges of the arms. Looking back toward the center, you see the dense concentration of old yellow and red stars, packed so tightly that if you lived on a planet here, the night sky would contain thousands of stars bright enough to read by, and there would hardly be any darkness left at all. Leaving the galactic center behind, you drift outward again, following one of the Milky Way's great spiral arms. The Perseus arm stretches before you, one of the four major arms that give our galaxy its pinwheel structure. Spiral arms aren't rigid structures, they're density waves, regions where stars and gas are temporarily compressed as they orbit the galaxy at different speeds, like traffic jams on a cosmic highway. As you drift along the Perseus arm, you see what makes these structures so visually striking. The arm is brighter than the space around it because it contains more stars, and particularly more bright, young, blue stars. These massive stars form in the compressed gas of the spiral arm and burn intensely for only a few million years before exploding as supernovae. Their short lives mean they don't have time to drift far from where they were born, so they remain in the spiral arms, lighting them up like cosmic lanterns. The sight is magnificent, a river of stars flowing through space, young blue giants mixed with smaller yellow and red stars, all embedded in glowing clouds of gas and dark lanes of dust. H2 regions, clouds of ionized hydrogen, glow pink and red, excited by ultraviolet radiation from hot young stars. Dark nebulae create shadowy lanes where light is blocked by thick dust, hiding what lies beyond. The overall effect is like a cosmic impressionist painting, light and shadow mixing in subtle gradations. The silence wraps around you gently as you drift along the arm. Despite the tremendous energies involved, stars being born, stellar winds blowing at millions of miles per hour, supernovae explosions releasing more energy in seconds than our sun will produce in its entire lifetime, everything unfolds in perfect quiet. Space cannot carry sound. All this cosmic drama plays out in absolute silence, perceived only as changing patterns of light and darkness. You notice that the Perseus arm, like all spiral arms, is temporary. Individual stars and gas clouds drift into and out of the arm as they orbit the galaxy at their own speeds. The arm itself is a pattern that persists even as the material composing it constantly changes, like a wave on the ocean, which maintains its form even though the water particles are constantly moving through it. This impermanence is somehow comforting. Nothing in the universe is truly permanent. Stars, planets, even galaxies eventually change and fade, but patterns and structures can persist, maintaining themselves through the constant flow of matter and energy. As you continue along the arm, you encounter a supernova remnant, the expanding shell of gas ejected from a massive star that exploded thousands of years ago. The remnant is a roughly spherical shell of glowing gas, expanding at several thousand kilometers per second, still hot from the violence of the explosion. In the center, invisible from here but detectable through other means, lies either a neutron star, a city-sized sphere containing more mass than the sun, or possibly a black hole, the compressed core of the exploded star. Supernovae play a crucial role in the galaxy's ecology. They're the primary source of elements heavier than iron, gold, silver, platinum, uranium. These elements are created only in the extreme conditions of a supernova explosion and then scattered into space, where they mix with interstellar gas and eventually become incorporated into new stars and planets. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created billions of years ago in supernova explosions, scattered into space, and eventually incorporated into the cloud that formed our solar system. Everything feels perfectly still as you contemplate this. You are, quite literally, made of stardust, atoms forged in the hearts of ancient stars and dispersed by their deaths. Every atom in your body except the hydrogen was created in a star's core or in a supernova explosion. You are not separate from the cosmos but a part of it, the universe's way of experiencing itself, consciousness arising from the same matter that forms stars and planets and galaxies. Your peaceful drift carries you outward now, toward the outer regions of the galactic disk. Here, stars become more sparse, the spiral structure less defined. The light level drops, darkness becoming more dominant as stars spread farther apart. This is the realm of the outer disk, where the Milky Way gradually fades into the intergalactic void. But even here, the galaxy hasn't ended. Beyond the visible disk lies the galactic halo, a roughly spherical region extending perhaps 300,000 light-years from the galactic center, containing globular clusters, scattered old stars, and something else entirely, dark matter. Astronomers have known for decades that the visible matter in galaxies, stars, gas, dust, isn't enough to account for their gravitational behavior. Stars in the outer regions of galaxies orbit faster than they should if only visible matter were present. The solution is dark matter, an invisible substance that interacts gravitationally but doesn't emit, absorb, or reflect light. Dark matter makes up about 85% of all matter in the universe, yet we don't know what it is. It's not made of atoms like ordinary matter. Current theories suggest it might be exotic particles that barely interact with normal matter except through gravity. The Milky Way's dark matter halo contains several times as much mass as all the visible stars and gas combined, providing the gravitational scaffolding that holds the galaxy together. You can't see the dark matter, of course, no one can, because it doesn't interact with light. But you can sense its presence through its gravitational effects, the way it shapes the motion of stars and gas, the way it holds the galaxy in a gentle embrace far larger than the visible disk. This invisible presence is strangely comforting rather than unsettling. The universe holds mysteries we're only beginning to understand, depths of reality we've barely glimpsed. And that's okay. Not everything needs to be understood to be appreciated. The silence continues to wrap around you, deeper here in the outer reaches where stars are fewer and the darkness more complete. Everything feels perfectly still, peaceful, as though you've reached the quiet outskirts of the cosmic city, where traffic thins and space opens up. The galactic disk is behind you now, a great wheel of light slowly rotating in the darkness. Ahead lies the halo and, beyond that, intergalactic space. As you drift through the halo, you encounter one of its globular clusters, ancient stellar cities containing hundreds of thousands of old stars. This cluster orbits the galaxy in a long ellipse, spending millions of years in the halo's quiet darkness before plunging through the galactic plane and then rising back into the halo on the other side. The cluster has made thousands of these orbits since it formed over 12 billion years ago, a faithful satellite attending the Milky Way through all its history. The stars in this cluster are among the oldest in the universe, formed when the Milky Way was still young. Some are over 13 billion years old, born less than 1 billion years after the Big Bang. Looking at these stars is like looking at cosmic fossils, remnants from a time when the universe was very different, smaller, denser, hotter, with far fewer heavy elements. These stars formed from gas that was almost pure hydrogen and helium, the primordial elements created in the Big Bang itself. Everything feels perfectly still here in the halo. The cluster drifts through space on its ancient orbit, its stars bound together by mutual gravity, their light adding only the faintest glow to the cosmic darkness. Time seems to stretch here, or perhaps to become irrelevant. These stars have shone for most of the universe's entire history. They will continue to shine for billions of years more, outlasting younger, more massive stars, patient survivors bearing witness to the cosmos. Your journey carries you further still, to the very edge of the Milky Way's influence. Here, the boundary between our galaxy and intergalactic space becomes fuzzy, ill-defined. A few scattered stars orbit in these distant reaches, expelled from the main galaxy by gravitational interactions or perhaps stolen from smaller satellite galaxies that the Milky Way has absorbed over billions of years. These orphan stars drift in near complete darkness, their nearest stellar neighbors light years away. But you're not quite done with the Milky Way yet. Even here, hundreds of thousands of light years from the galactic center, you're still within the galaxy's extended halo, still feeling the subtle influence of its gravity. The Milky Way, like all large galaxies, doesn't have a sharp edge but gradually fades into the surrounding space, its influence extending far beyond the visible disk. Looking back, you can see the entire galaxy spread out before you, a great spiral of light in the darkness, slowly rotating, its arms traced in blue and white where young stars shine, its center glowing with the accumulated light of billions of older stars. The sight is breathtaking in its beauty and scale. This is your home galaxy, the cosmic city that contains all of human history, every person who has ever lived, every story ever told, every dream ever dreamed. All of it contained within that spiral of light. The silence wraps around you, profound and complete. Everything feels perfectly still here at the edge of everything. The Milky Way rotates in the distance, its spiral arms turning with patient slowness, each rotation taking 250 million years. You float in perfect peace, suspended between one galaxy and the rest of the universe, a consciousness contemplating the cosmos from a vantage point of infinite serenity. From this distance, you can see the Milky Way's satellite galaxies more clearly, the Magellanic Clouds, two small irregular galaxies that orbit the Milky Way like faithful companions. The large Magellanic Cloud contains about 10 billion stars, the small Magellanic Cloud about 3 billion. These galaxies are bound to the Milky Way by gravity, and in some distant future, they may merge with our galaxy, their stars mingling with ours in a slow cosmic collision that will take hundreds of millions of years. You also notice other, even smaller satellite galaxies, dwarf spheroidal galaxies containing only a few million stars each, orbiting the Milky Way in the halo. Astronomers have discovered dozens of these small satellites, and there may be hundreds more yet to be found, too faint to detect with current telescopes. Each one is a tiny stellar community, bound together by gravity, orbiting the Milky Way through the darkness. Everything feels perfectly still, yet you're aware that all of this is in motion. The Milky Way and Andromeda are approaching each other at about 70 miles per second, drawn together by mutual gravity. In about 4 billion years, they will begin to merge, their stars passing by each other. Space is so vast that actual stellar collisions will be extremely rare, their gas clouds colliding and triggering bursts of new star formation, their supermassive black holes eventually spiraling together and merging. The result, billions of years from now, will be a single enormous elliptical galaxy, sometimes nicknamed Milkometa, containing all the stars from both galaxies. But that's far in the future. Tonight, the Milky Way exists in peaceful equilibrium, its spiral arms slowly rotating, its stars shining steadily, its planets orbiting those stars in ancient rhythms. And you float here, suspended in cosmic peace, contemplating it all with a sense of wonder and belonging. Time to begin the gentle journey back. Not back to Earth, not yet, but back through the galaxy, retracing your path to the spiral arms, past nebulae and star clusters, to the spaces between stars, each one a sun unto itself, each one potentially surrounded by planets, perhaps even life. As you drift, the silence continues to wrap around you like a soft blanket. Everything feels perfectly still, perfectly peaceful. You're no longer thinking about facts and figures, about light years and stellar masses. You're simply floating, existing, being present in the vast, gentle darkness of space. You pass through a cloud of molecular hydrogen, the raw material from which stars form. The cloud is cold, just a few degrees above absolute zero, and dark, blocking the light from stars beyond. But it's not empty. Molecules drift through the darkness, hydrogen bonded to hydrogen, and more complex molecules too. Carbon monoxide, water, formaldehyde, ethyl alcohol. Space is not sterile but filled with chemistry, molecules forming and breaking apart, the building blocks of life scattered throughout the galaxy. The cloud is so vast it would take light thousands of years to cross it, yet you drift through it effortlessly, consciousness unbound by physical limits. The darkness is comforting rather than frightening, a gentle cosmic womb where stars will someday be born. Everything feels perfectly still here. Time means nothing. You could drift here forever, suspended in peace. But you continue onward, emerging from the cloud into a region where young stars shine. These are newborns in cosmic terms, perhaps only a few million years old, still surrounded by disks of dust and gas from which planets are forming. You drift past one such system and see the disk clearly, a thin plane of material orbiting the young star, gradually clumping together through collisions, building up into larger and larger bodies. Dust grains become pebbles, pebbles become rocks, rocks become boulders, and eventually, over millions of years, boulders become planets. Watching this slow process of creation fills you with peace. The universe builds things gradually, patiently, without hurry. Stars form over millions of years. Planets take tens of millions of years to fully coalesce. Life, when it emerges, evolves over billions of years. There's no rush in the cosmos, no deadline to meet. Things simply unfold in their own time, according to physical laws that have remained constant since the beginning. The silence continues, profound and complete. You drift past more stars, each one unique, red dwarfs that will shine for trillions of years, yellow dwarfs like our sun, white dwarfs cooling slowly like dying embers, red giants swollen to enormous size, blue giants burning fierce and fast. Each star is at its own stage of life, following a path determined by its mass, living out its destiny in the cosmic darkness. You're floating now in a particularly quiet region of space, between the spiral arms, where stars are sparse and the darkness is complete. The Milky Way spreads out around you in all directions, a river of light flowing through the cosmic void. You can see it all from here, the whole magnificent structure of our home galaxy, slowly rotating, peacefully existing, holding within it everything humans have ever known. Your breathing has slowed to match the patient rhythm of the cosmos. Each breath takes a lifetime of stars. Each exhale releases 1 billion years of cosmic time. The silence wraps around you completely now, a presence rather than an absence, the fundamental quiet of the universe itself. Everything feels perfectly still. The frantic pace of Earth life has fallen away completely. The stress and worry and constant pressure to do and achieve and accomplish, all of it gone, dissolved in the vast peace of space. Here, in the cosmic darkness, there's only being, only existence, only the gentle drift through infinity. The stars glow softly all around you, their light ancient and pure. Some of that light began its journey before humans existed, traveling for millions of years through the vacuum of space to arrive here, now, illuminating this moment of perfect peace. You are floating in ancient light, suspended in time, cradled by the galaxy itself. Let yourself drift deeper now. Deeper into the darkness. Deeper into the silence. The Milky Way continues to rotate, its spiral arms turning with infinite patience. Stars continue to shine, fusion reactions in their cores converting mass into energy, light radiating out into space. Planets continue their ancient orbits. And you simply float, suspended in peace, consciousness dissolving into the cosmic whole. The galaxy holds you gently, like a parent holding a sleeping child. You are safe here in the darkness, protected by the vast distances of space, cradled in the silence. Nothing can harm you. Nothing can disturb your peace. You are floating in the heart of the Milky Way, surrounded by stars, held by gravity, suspended in time. Let go now of all thought. Let go of facts and knowledge and understanding. Simply drift. Simply be. The galaxy exists. The stars shine. And you float in perfect peace, consciousness becoming as light as starlight, as vast as space itself, dissolving gently into the cosmic darkness. The silence is complete now. The darkness is total. But it's not empty or cold or frightening. It's warm with the light of 100 billion stars. It's full with the presence of the galaxy. It's alive with the gentle pulse of cosmic time. Sleep now. Drift now. Let the Milky Way carry you gently into dreams. Let the stars sing you to sleep with their ancient light. Let the vast spaces between stars cradle you in their peaceful embrace. You are floating, drifting, dissolving into starlight, becoming one with the galaxy, one with the cosmos, one with the infinite peace of space. Sleep, drift, float. The Milky Way holds you, the stars shine for you, the cosmic darkness embraces you. Everything is still, everything is peaceful, everything is perfect. Sleep now, drift now, rest in the heart of the galaxy, rest in the cosmic peace, rest in the gentle darkness between stars. The galaxy rotates slowly, stars shine softly, and you drift, 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 into sleep, into peace, into the infinite cosmic night. Sleep, sleep, sleep.